our slides. So it should be up there for you, making their way through the internet. So I'm going to probably turn off my screen because I'm using the data signal. So save a little bit on our internet usage. But that doesn't mean if you don't have questions or chats, feel free to use the chat, the Q&A, whatever we do to make sure we can answer any questions you might have along the way. If you can't hear me, please make sure that or if something happens, if I start to get a little wonky in the signal, please let me know so that I can go ahead and see what we can do to compensate for that. But let's go ahead and get this back. There we go. So today's class is building on our plan review series and looking more at the mechanical system. And what are we looking for in mechanical plan review that relates itself to energy code compliance? So it's not a class on mechanical plan review, it's a class on the energy implications during mechanical plan review. And so I just want to remind you about the resources that are available. Again, we've talked, Hope is in communication with our IT on how to better facilitate the website. But if you do have questions about different trainings, if you're not finding something online, or if you need some of our technical documents, you want a refreshed list. I think that's something we're going to be doing. We were talking about it this Monday. We'll be doing a refreshed listing and then sending that out and saying, hey, if you don't already have these information, if you want some of these technical documents or resources, reach out to us so we can make sure you get them. I know Hope's I think we'll be in Hobbs in a couple of weeks on the 10th. So for those of you that aren't already registered, signed up, and sent her an email, right? Make sure you send her an email, letting her know you're coming. When she gets there, maybe there's some things that she can download for you. Maybe do one thing I love to do. I usually carry around a bunch of flash drives in case we need to download stuff. So that's always a good way, in my opinion, to share some of the information. So minimize this a little. I don't know how. Anyhow. So again, if you have any questions, please let us know. Now, when you've heard it, when I taught yesterday, teaching today, and I'll teach this afternoon. You know that if one of the first 3 to 5 slides is going to be this statement, that if we understand the what we're doing, we can figure out how we're going in your brain this concept of why am I looking. Okay, is everybody still there? Hopefully. Okay. I just did the dastardly deed. I unplugged. I guess the Wi-Fi signal wasn't going to work, so I just took the Ethernet out of somebody else's computer and plugged it into this one. Sorry, it should be fine until the system. So it's not. I got a couple yeses. So I'm glad you're still here, Jerry, because now I am too. So again, sorry. But so usually in those first few slides, we're talking a lot about how we evaluate why we do what we do, why we look at energy, why we look at any of these things is provide uniform expectations across the state and how buildings are built. When we think about the state, when the state adopts a new code, it's doing so to create uniformity, right? And to create and to extend the purpose that we find in these codes to our buildings. And when we talk about mechanical systems, we got the UMC as the state's adopted method of evaluating mechanical systems. But we'll see that what we're looking for are some basic concepts when it comes to energy that affect those mechanical systems, right? We have minimum standards for how those systems operate. And again, that includes those energy related uses and systems. Make sure now everybody's seeing the screen. Okay, we're good. We're good. So when we think about the purpose, and that purpose is again not specific just to the UMC. It also it's there in all the mechanical related codes. If we looked at ASHRAE standards, we look at the International Mechanical Code. All of them have this expectation that we're providing uniform, consistent ways to meet the needs of the building space. And when we get to that energy code, we know whether it's residential or it's commercial that what we're looking for is that innovative and flexible method for, again, providing a building lifelong awareness to how much energy is used in that process. So let me do this real quick while I've got a better, more stable internet, maybe. I will try to upload those slides once again for those of you that want to take notes along the way. So again, that concept that we see provided, again, it exists both in the commercial and in the residential. We're looking for innovation. We're looking for flexibility. And one of the things we have to start thinking about is how do we design a building? And I think this is something that we're going to see more and more is new technologies. I just taught a class yesterday on A2L refrigerants and how that's going to affect mechanical system selections and the expectations we have there. I'm teaching a class today on the manual J calculation for jurisdictions that are just moving into that, really hitting it hard on using that method of determining energy or determining mechanical system loads, right? The code is looking to make sure that we provide innovation flexibility. I can get away. We've talked about this, I think, last week in one of our classes when we talked about res check. I can get away with, I say get away because it's not really a fight, but I can use an R60 in a roof application, or I could use an R38 with 10 continuous. I looked at one yesterday. I was doing a project for my home state, and the alternatives to an R30 wall insulation include an R19 with a 7.5 continuous. So I don't have to look at. I can do an I think we looked at an R13 with 7.5 continuous, and you can get close enough in some climate zones to make it to be able to say this building meets the minimum requirements of the building's thermal envelope. Because what we're really looking at is how does all this work together on paper to provide a building that works, right? A building that meets that that minimum efficiency that we provide, that we're expecting out of buildings. And remember, this is part of that holistic approach to how we look at the building. We've talked about those 4 key components, those primary pillars of energy code compliance and of a building, and honestly, and we have you could take these 4 concepts, and I think you could very easily take one step back and see how the thermal envelope is the same as our framing and our exterior structural frame, right? That the air barrier is that exterior coating, right? You can see how that these concepts exist in the building process now. Obviously, mechanical systems and power and lighting systems are parts and components of what we expect. And when I say mechanical, that extends to an extent into the plumbing, the sanitation side of it. But more importantly, when we look at these concepts in general plan review, we can see how we can refine, maybe focus our glasses a little more and really get into how energy affects each of these systems. And like I said, that's how I came up with these 4 components that I hit on and reinforce time and time again, right? It's that thermal envelope, that air barrier, mechanical, and power and lighting. And so when we start to move into today's conversation on mechanical systems, we understand that there's going to be some things that we're looking at today that maybe we didn't focus so much on in the past, but honestly, it's always been there, right? Section 403 in the mechanical code, again, whether that's in the residential provisions or the commercial provisions, is really giving us this guidance. And there's a lot of, there is a lot to unpack in section 403. And so today is probably going to, if we really wanted to, and maybe this is something we talk about, is doing a deeper dive into the mechanical code provisions, the mechanical section 403 in more detail. Maybe that's something to come back with. I would always invite you to, if you think that's something you want to do, put it in a Q&A, put it in your survey, so that we know we can say, hey, we want to do this. And do we want to do it virtually, or do we want to do it in person? I did a class recently over in Texas for plan review, and we did it in person because they wanted to have their code books with them. They wanted to sit down and actually talk. I'll be honest with you. We all know that when we have 50, 60, 50 people on a call, it's sometimes intimidating to ask questions. Yesterday I taught, there was about 25 of us, and it was a great opportunity for jurisdictions to ask. And so again, I love to do in-person trainings, and No Hope loves to do it. We'll do that one in Hobbs in a couple weeks. But again, if there's things we can talk about, always put that in the Q&A or in your survey, so we can go back to our team and say, hey, this is something we need to really dive into. Again, sorry, digression there. But there's a lot of things to unpack, and we can't do all that in an hour. And so if we were to really look at it, if you break down all of the sections and subsections and chapters in section 403 alone, this is what you get. Just going to the major subpoints. And that's not to mention the 18 tables that come in section 403 for efficiency calculations. I think that's a conversation in and of itself, just to look at those tables. But what we do know is that any time we review any project, we need to understand those. For plan review, we need to think about that energy compliance path. Again, residential, we know what those alternatives are, right? We have our prescriptive, our performance, our energy rating, and other programs. And so it's really important for us to know which one we're following, so we can say, are we applying the minimum prescriptive requirements on these mechanical equipments? Or is this mechanical upgrade that we're seeing come into the project really because they're taking advantage of some performance gains, right? That's usually a big part of that conversation. And that extends again to the commercial as well. Whether again, we're looking at prescriptive or performance. And if we go to ASHRAE, we know ASHRAE has prescriptive and performance as well. So that's why, I think it's, even though it sounds like it's a broken record, you hear me say it a million times, because it really, to me, is crucial. Every time I do a plan review, I always find myself, I've told you before, I'm old school, so I still carry a pen and paper when I do plan review, and I take notes, and then I put it back into the email or into the Word document, right? And one of the first things I write down at the top of the sheet is the compliance path and obviously climate zone, right? Because we know jurisdictions have, you get used to your climate zone. I have to remember which one I'm looking at. But more importantly, every paper I put down, am I using prescriptive? Because as I get deeper into this project, right, a residential plan review may be 3 to 5 pages. Whereas a commercial project, if we're looking at a large new hospital, or we're looking at a big project, it could be 30, 40 pages of mechanical drawings. It could be part of a 300 to 400 page packet that we're getting. And so for me to come back and say, okay, what was I looking for again? It really does create that problem of keeping track of the whole project. Now, I will tell you, I was talking about this yesterday, and I think we'll have something before Hope makes it to Hobbs. I take a step back here. Our energy plan review guide, we are working very diligently. I've got a deadline on my side of it of next Wednesday to have the first draft of this guide done. We've provided you with the inspection guide. This takes it into that plan review side. What are those things that we're looking for in plan review? Now, what I'll tell you, this is how I do it. And again, we're all different. I know there's a lot of forms out there and people use a lot of print-offs and paper. I'm too conservative when it comes to how much paper I use at my house. It's my house, right? And so I have laminated my plan review checklist, right? And then I'll take a Sharpie, or not even a Sharpie, an Expo marker. And as I run through those projects, you can kind of see, and I hit it intentionally so that you wouldn't know exactly what it says yet. But when I go through and I'm looking at load calculations, I'm looking for controls, or the economizers are in place, if there's going to be something else like that. When I'm doing all those plan review components, I'm checking them off with an Expo marker. And that way at the end of the project, right, this will sound weird, and if we do it in person, you would see it in reality. So I have the plan, I've got the screens on both sides, and then I've got a piece of paper, I'm taking notes, and I've got my laminated plan review checklist next to me. So I can highlight, scratch off, and then wipe clean and keep one piece of paper, right? For my plan review. So I'm not printing a million pieces of paper in the process. Each one of us is different. Each jurisdiction is different in what you provide. Maybe you put it into your submittal packet, right? Different information, different ways to do it. But what we're really looking for is the basic materials, the basic information that should be part of that plan. And the code gives us a list in section R103.2 and C103.2 of that listing. Now, when you move to 24, they renumbered it to section 105, but we're not going to talk about that right now, right? And we also get a list of the expectations from the NMAC itself, right? But this is what we're thinking about when we talk about energy compliance. And what we want to know is, again, between residential and commercial, is what is the design? Show me, please tell me that you've done it, that you calculated which piece of mechanical equipment is supposed to be in this building, right? Because too often what we'll find is, no, we didn't. We just this is the last thing that we did, and this is the one we bought, right? So you want to know those pieces of equipment, their efficiency, their types, their fuel systems, their ventilation, their fan systems, right? What is the ventilation requirements? How are we going to get this moving around? What does that duct look like? How are we transmitting this conditioned air around the building? These are all pieces of the process that I think is really important. Well, obviously the code says it's super important for us to have. It's something we have to have. And a lot of times I get it, well, I live in the same world you guys do. We approve plans, and then 6 months, 8 months, 9 months later, we get here's the mechanical, for final review. I just got an email from a contractor today where they're saying that they can't provide some of this information because it's not been selected yet. And I'm going to be honest, I'm going to write a nice little letter back saying, well, then then you're going to check with the building official, because again, I don't see how you've not picked what size of equipment you're going to have. You've already decided how big the house is. You've decided how big the room is going to be and what you're going to do in it. What is the big hang up in saying we need this size equipment? They were saying we don't know what fireplace we're going to buy. Oh, but you've already figured out what it's going to fit in. Don't get me started. I get a little antsy when it comes to plan review. But again, this is the type of information we need in the code. And so what are those expectations when we start talking about plan? We're talking about, I need loads, I need ventilation, I need equipment for efficiencies, right? I try to, again, break this down to some basic expectations. I said I have 4 key pillars of energy code, of the building systems, and then I have 4 key sections each time I look at anything. Now, again, there's always more than 4 things on my list, but the 4 big things that I always make sure we hit are going to be that load calculation, right? That mechanical ventilation. You're going to know how much air we need in that room. One of the things that we're going to see, especially in residential, moving forward, is once we get into A2L refrigerants, you're going to have to know how much, what's a volume of air you need to get into a space in order to reduce any potential flammability issues should you have a leak. So you have to know that ventilation expectation. When you get into HVAC equipment, the actual equipment, how is it performing, right? When do we need commissioning? When do I need to have that second person come out and actually make sure the system does what it's supposed to, right? Activates. And what do you do when a system requires commissioning that takes longer than you're going to have before you issue a C of O? Do you issue a temporary? These are conversations that again are a little bit deeper in reality, but we can, again, what is that duct system going to look like, and what are we going to do as far as controls for it? And a lot of that information can again come out of that documentation that we get provided, right? If I see a comm check that incorporates mechanical components, I understand that this is not perfect, but it's going to give me a sense of what I'm expecting to see. If I see they've identified 3 systems, a water heater and 2 rooftop units, and then I get the actual plans and I've got 7 different pieces of equipment, then I'm going to have some questions about where's the consistency throughout this entire project, right? If I see that we're doing an energy report where they're actually utilizing specific energy efficiencies in order to justify other trade-offs, then I need to know that so that again I can verify that in the totality of what I'm doing. So let's get into some of this code expectations. Now, Section 403 tells us that we need to have those design loads for heating, ventilation, and air conditioning of the building, right? So if we're going to use these systems, we either find ASHRAE 183 or some equivalent method of calculation. You need to provide a calculation of those heating cooling loads, right? This is not just something that the energy code sees. That this is something we find in the UMC. We find this in the residential side of the conversation. We need to have these evaluations on what is that cooling and heating load calculation. Now, we've talked about this before. The code says you just have to provide heating in a building, right? We all know that. It reach 68 degrees at 3 feet off the wall in an occupied room. But if a project is going to provide, so there's no mandatory requirement, at least not yet, and didn't make it in the conversation yet in the 2027 as well. There's no requirement to have cooling. But if you're going to provide cooling, then you have to evaluate it. You can't just throw in a little bit of cooling and say, hey, this was a little extra for you. Good luck, right? And I think that we understand why that is. You can always open a window, you can ventilate, you can turn fans on, but when it's cold, you can't do much more, right? You can't start a fire in the middle of the house because it's too cold outside. So that kind of reinforces why the code as a whole, the IBC, the IRC, really only shows us those heating requirements. But once we get into mechanical systems, we're looking at how they work. And again, that's not just an energy code conversation. That's something we see in the UMC, the IMC, and again, when we look at some of these ASHRAE standards. And so again, in residential systems, we're using that manual J, manual S as part of that system. What we're looking for, and again, I want to make sure I reinforce this, as a plans examiner, I'm not recalculating anything. What I'm making sure is that the numbers, that there are certain key factors in that evaluation that make sense, right? I'm going to look at those outdoor, and really I've kind of reduced those to load capacity, compliance, capacity compliance, means compliance, right? Load and capacity means compliance. And so when I start looking at a load calculation, I'm looking for certain elements like my design criteria to make sure it reflects the appropriate outdoor temperatures. I've seen some that have been set 1 or 2 degrees off, but I've also seen projects where they come in. I've got one that was in Minnesota here. It was 17 degrees off on that cooling load, right? That's a significant amount of difference for 99% of the year. Now, remember, this is not to say I've tracked the weather station and I know exactly what it's going to do tomorrow. We're looking at ASHRAE standard. ASHRAE puts together these work tables, and so we can calculate and have some basic averages of 99% of the time, 99.6% of the time, we're going to be able to handle this temperature, either highs or lows. Same thing with you guys. You know, if I told you that the maximum design temperature is 92 degrees, guess what? That's not going to work down in Roswell, in Chavez County. I can tell you right now, because you're going to have more than 1 or 2 days in the course of a year that are going to be above 90. You're probably above 90 now, and it's only 9 a.m., right? And so that's part of understanding, did we get the right design? Right? When we start thinking about it again in this context of even our simple convenience store we've talked about before, I'm looking at that outdoor temperature, that indoor design temperature for heating and cooling days, and I'm looking at what all's gone on to get me to this place. Now, a lot of times I want the more detailed review, right? But most of the times, even the short form will give you some of this information to show me that you've calculated for some of the wall, roof, windows, and skylights, all of those different components that are going to affect heating and cooling laws, right? And so that's what we're calculating, is how much the building and the occupants, the people, impact the overall requirements of the building, right? And then we'll need required amounts of ventilation. We'll talk about what level of air leakage do we have. That's always a piece of it. Is this a tight this construction? Is this a semi-tight? What's the air? What is the anticipated air leakage rates? Because that's going to affect what kind of equipment I put in. But for this project in particular, we saw that the heating loads and the cooling loads were 203 MBH and 228 MBH respectively, right? We see those values. We can see them at the bottom of the table. We can also see our design cooling load, right? We're designing for 94 and 17. Oh, wait, that's my point. My design heating load is 97. My cooling load is 97. My heating is 17. But what does my design show? It shows a 92 and a -2, right? So it's going to be oversized. It's thinking it's going to be -2 for a portion of the year, when we're saying it's going to be above that at 17. So again, we're going to be oversizing that equipment. Now, the code currently doesn't say, there's some guidance as far as industry-wise as to how much overage you can have. But in future editions of the code, this is the area that people are getting at more and more. I think Minnesota just adopted a code, or is in the process of adopting a code that puts commercial limits at 40% over that calculation, and residential at 15% over. And so if you design a building that's 15%, 20% oversized, then you're technically no longer compliant with the code, right? So currently, the current New Mexico edition of the UMC does not provide that guidance, but I'm telling you, it's going to be coming soon. Everybody's moving that way. Wrong direction. So again, what I'm going to be looking at is I'm to get that maximum heating capacity. So I've got what the load tells me I need. I need 203 and 228. I start adding together these pieces of equipment to calculate what is my capacity, right? So I can go to that calculation. Again, not every plan has the same information. I think that's aggravating and frustrating. I do my best to train architects, provide this type of output information. What is my heating equipment going to be doing? What is it going to be providing me when it comes to the cooling of that system, right? What are those efficiency ratings? Again, I think that's one of those things where if we can get that information as upfront, as close to the beginning of the process, it's going to make life so much easier. Even if these are minimum expectations, right? You could say, I am accepting of the idea that you're buying a piece of equipment that meets this minimum output of heating, this minimum output of cooling, and it's going to have a minimum efficiency of this. If you get something better, great. If not, at least we have a minimum that we're looking for, right, to evaluate against. But again, I take that load, all those individual elements, I add them together. I can see that I've got enough capacity to meet the load demand. And like I said, we're seeing here this 446,000 BTU of heating is almost double, what we're going to need to meet the load requirements of the building. And especially if I'm building this and again in a Roswell or a Clovis, right, or a Hobbs, I'm probably not going to need that much overage. And again, that's where the code is coming in future editions to say, wait a minute, you oversized too much, right? That's how we determine when you've oversized too much, right? But again, those are things for us to start to identify and really bring to the conversation. I say it that way. I do have conversations all the time with architects and designers who ask, well, is this the minimum requirement or is this just some best practice? And I'm going to tell them that, I'll be honest, depending on what it is, it might be a best practice, but that's also part of, sometimes it's what I need. One of the questions we'll get to at the end of this, hopefully, as long as I don't talk for too long, is really one of those things where best practice and what I'm expecting from my staff is that you provide this information, right? So some of this is making sure this is minimum requirements, that we make sure that the load of the equipment matches with the design of the building. Some more examples, things we've talked about before, and then we're going to make sure that the equipment matches that load, right? I didn't recalculate the load. I'm going with your load. I'm just making sure that everything matches and we can meet that load. I see your equipment that they have identified. They provide it with a comm check. Not every project does. So then when I have a comm check, it makes it easier. If I don't, I'm going to go and I'm going to look at that individual piece of equipment that was rated to provide 130,000 kVH of input, right? I see that we've got that system, and it's supposed to be 80% efficient because of the gas-fired furnace. I'm going to have to go to the table, find the right section, verify the size, and then evaluate the efficiency, right? Whether I do that from a comm check or I do that from the report, right? In digital form, I'll be honest, one of the things I do with my PDFs is I highlight in yellow if it's for me, and I highlight in red if it's for them, for the response, right? A lot of times I'm tracking my comments personally through, even sometimes through that, or things I want to go back and double check to make sure. And so like I would more than likely highlight that 130, put in, 80% by this, right? And so then I'm going to see where that 80% value is in this table, right? We're not seeing that efficiency listing. We've got a comm check that says it's required to be, proposed to be at 80%, but I'm not seeing that here. And so I'm going to have to go through some specs. And 9 times out of 10, it's send me the details because you didn't include those, right? You told me it was a train, and I'm not looking up the train model because I could be there all day, right? You're going to have to send that one back to me. Same thing with the cooling section. We're going to verify and apply, right? We see this again, that same system that we're talking about, providing that 56,000 BTUs in cooling, which we see it's not really, it's 52. We go over here and it's showing me an equipment efficiency rating of 13. Well, they told me it was proposed at 15. The minimum was 14. I've got some questions here, right? Is it because you're looking at a SEER versus an EER? Or is it because, again, you've got the wrong, the inefficient, the incorrect piece of equipment, right? These are things we're going to be verifying. It's all about verification. After we get through that design and we get into those controls, again, we want to make sure the controls are there. 9 times out of 10, we know there's a variety of different expectations with those controls as far as how they operate, what they shut off, especially when we start talking about new technologies and new requirements on certain types of refrigerants. We talked about this all day yesterday, again, about the A2L and how that's going to affect some of the controls that need to be in some of these systems, especially with existing equipment that comes in for repair or some kind of upgrade or modification, because you have certain control expectations. So you have control expectations from an energy perspective that are going to be different from what we find in the mechanical code, right? Mechanical code is going to say, hey, if you have a refrigerant leak, what are you supposed to do? Shut down the system and do something, right? And so again, if I'm in the process of reviewing those things for code compliance, I'm going to be available to do that again for energy efficiency as well. And a lot of times, what I find more times than not are that those are going to be in keynotes, right? There's going to be some type of of notation in the notes that tells me what I'm looking for. Right, it's telling me where those thermostats are going to be located. It's telling me what those temperature sensors are where they're going to be and how they're going to operate, or again, some other advanced details. So again, that's what I'm looking for, is what am I going to find when I go to look for that building, and what is my inspector going to be looking for? And so when he gets on site, he knows where those different pieces, those different devices are going to be located, so that he can say, these are the thermostats and this is the sensor that was identified. Okay, so now we know where they're going to be. And then we can verify very quickly whether we do that through commissioning, 9 times out of 10, or some kind of certification from an installer that says, look, we've got our one, it's programmed to do these things. It's programmed, it's capable of doing these things, right? That sequence of operations is going to be important. Again, when we start talking about commissioning plans and what those expectations are for some of these equipment, that's going to be something that maybe we defer to the commissioning report that says, hey, look, they made sure that the equipment was there. I'm not walking around 300 different hotel rooms checking to make sure that the air conditioning system works and works in this way, right? I'm not going to check to see if it shuts off after 20 minutes after I leave. You're going to have to do commissioning to do that. Because if I'm going to do it, it's going to cost you more than $75 for an inspection or whatever I prepackaged into that permit. So again, there are some considerations we need to think about on both the residential and the commercial side. There are rules and guidances for each pieces of equipment when they work in tandem to serve a multi-zone system, or again, if we're looking at multiple pieces of equipment to reach overall building calculation of what those individual efficiencies versus group efficiencies are going to be. Again, we find that in the tables. And one thing I really think, I was doing some review yesterday for a class, and one of the things I think is important, we're trying to put together some questions to do a certification training program class and for mechanical. And one of the things we looked at was, what do the footnotes say? I mean, how many times do we ignore footnotes and never really pay attention to those footnotes? And then we find out, oh, wait a minute, there was a complete and total out on a project, because if I'd read footnote M, I would have seen this. So again, I think it's important to every once in a while remind ourselves that the code has changed, and not just always in the big ways we see it. There are sometimes little things that we start to identify. And again, same thing with exhaust systems. I'm going to be looking at those, making sure I have the appropriate airflow that matches with my outdoor air ventilation schedule, but then also making sure that those fans, whether they're integrated or not, have the appropriate efficiency. So after I get through the equipment, then I get into the duct system itself, right? We understand there are certain expectations about the method of construction, whether they require insulation or not. That's always one of those key conversations, right? Where is it in the context of the building thermal envelope? Are you still requiring it as part of some other purpose for managing maybe air leakage or duct leakage versus condensation control? There are a million reasons why you could insulate a duct, and the code gives us 1 or 2 good reasons, right? Because we're trying to reduce the amount of heat loss and the amount of condensation associated with the duct as it moves throughout the building. But when we start talking about, where those ducts exist inside the building, that's when we start talking about the level of insulation based on the size of the duct, right? And so again, those are certain requirements that every once in a while, I'll see a note in a section, and I know as soon as I open that note page, usually on page 2 or 3, the page after code analysis starts. Usually it's a direct copy from the codes. And it's they're just trying to placate the actual, the plans examiner, but at the same time, do you even have those systems in play? I talked with the designer yesterday. They were like, hey, this is the first time we've done one in a while. What do you think about, what should we do? And the information I said was, honestly, one of the things that I find the most problematic is people just copy from the book thinking that's going to make the solution. Well, that just holds you to a different standard than what you could have had. If you weren't going to choose if you're not going to go with an R20 plus 5, if you're not going to go with an R8 or insulation around this duct because it's inside, then don't list it, right? If you're going to say everything is going to be in a conditioned space and therefore doesn't require any additional insulation, then then say it, and not again. And then evaluate where those show up in that design, right? We've talked about this image before of the loading space. I've got a question I got from a team yesterday about a remodel where they're saying this vestibule is now going to be a loading dock. Well, what does that mean? Well, if it's a loading dock, then it's an uncontrolled space. Then yes, they're going to have to insulate, especially along that water line, that serves the building's fire suppression system, because this is one of those cold climates that again has if it's open for 45 50 minutes to a couple hours because it's a loading dock at a retail space, I'm not sure what's going to happen to those water lines that weren't that previously were part of an enclosed and conditioned space. They're going to knock out a wall and turn it into a loading dock. Okay, that they're changing something. And so again, we start to think about how those ducts are impacted, and again, how they're impacted by that thermal envelope across the building, right? Is this an exposed duct system, which it appears in certain areas to be? Or we have some areas where we're going to have drop ceilings and some areas where, again, that thermal envelope's up here. So I don't need to worry about as much these lower spaces or these semi-controlled areas. But I do need to make sure that I've identified where that thermal envelope is in both a traditional elevation as well as in my my bird's eye review of my building plan. The one thing that I get the most conversation on is, again, this idea that I need to know what type of ductwork is going into the building, right? Especially with residential. I don't know why, but everybody wants to use, we tell people we're going to use a certain type, or we in that design start listing item numbers, right? Elbows and fittings and but we're giving it a manufacturer's designation, but we're not telling the building official what they're actually looking for. Am I looking for some type of a veined or ribbed elbow or a smooth elbow, right? What am I looking for in this design? And so again, how do I have these transition spaces where we have a different takeoff? Some are going to be round, some are going to be square. That's going to affect a lot of the design, especially when we start talking about air velocity and dampers and those kinds of things. And so again, we want to have that information as part of the process. So we want to make sure that is part of the duct evaluation when we do our plan review. There's also the code identifies protection of those piping systems. Again, we see this in the plan where it says we're going to have something that's going to be exposed to UV rays or maybe to weather or other potential damage. We want to make sure we protect it, we shield it again. And that's both found both in section 403 and 404. We start calculating those distances of what needs to be insulated in order to maintain those temperatures. And one of the things we see in the future versions of the code, and I see this all the time, where we see in the 2024 version of the code, it references both in those tables, both a thickness measure, a number of inch, an inch minimum or whatever, what have you, based on material types, as well as the R value. Now, what I end up, again, sounds like a stupid note, and I always hate to put it in there, but I understand you're going to insulate these pipes, and you're going to do it with some different insulation sizes. What I need to hear somewhere in here is that you understand that you have a minimum thermal resistance value associated with these designs. So whether or not it's still going to be that minimum R3 when we start talking about it, not just 1 inch or that kind of thing. We want to make sure that we recognize it's thermal resistance, not just depth of insulation. So normally, again, it's a comment that's very quick, very easy. Hey, make sure you throw this in there. So same thing for when we talk about whether or not a design is going to incorporate heating outside the building. Again, how are we going to evaluate it? And those controls. I see a lot of time where we have identified potential snow melt systems, especially in those higher elevations or part of those areas that do have more cold climates. I've even seen the opposite of a snow melt system, which is a cooling system. Was a very nice home that didn't want there to be. They wanted to be able to walk out on their deck or out on their concrete walkways, and so they didn't want to have to worry about wearing flip flops and sandals. And so they literally installed a cooling system in their concrete. Let's just say that's probably not something you're going to see on every project, but in those, I treated it the same way I treat an ice melt. Right? I want to make sure that when it's 12 degrees outside, And that one time of the year when it's cold, that you're not going to be trying to run cold water through this system, causing uh, damage, right? Because we know what's going to happen. If it gets super cold and you're running water, even if you're running that water, it's going to freeze, it's going to buckle, it's going to bust. And so we want to make sure we think about those. And again, whether it's snow melt or cold dampening, I don't know how you want to call it. Make sure we think about those systems, and then what kind of other things we're doing to protect the building, how we're tracking and where that sensor is. Again, it gives my inspector the ability to go out and verify that. Where's that sensor? Oh yeah, so that's what that is. Okay, there's your sensor telling you that this is the outdoor temperature to shut off that heat trace tape or that snow melt system. And then also like I said, this is a little bit of the other one, talking about those interlocking openings. So traditionally we think about these kinds of things, but maybe in a remodel, we need to, again, reinforce that when we have these large openings, it's not just sealing that dock, but it's also making sure that when it's open for extended periods of time, that we are reducing the expectation for heating and cooling in those zones. Because we're going to, especially depending on the design and what type of building we're looking at, we're going to have areas that are going to, if uncontrolled, are going to significantly increase the amount of energy that a building is going to be using because of something as simple as the loading dock is still open, right? And again, think about those and where is it in 9 times out of 10, like in this particular design, this is not part of the building thermal envelope. So it's outside of that thermal envelope. I'm not concerned about that opening here because my thermal envelope, if we had the picture further over, is over here, right? So this is a general receiving area. And then we've got a series of doors that are interlocked in order for us to move this material into the interior storage area. I see a lot of this. We have a lot of food storage facilities, excuse me, and food processing facilities. And so we have conditioned cooled areas for food, but they're delivered in these kind of, we have, again, this is something we see a lot of, delivered in these open receiving areas and then moved into the conditioned spaces by staff. There are other resources, and again, I just remind us about the ComCheck, res check that we talked about last week. Res check, ComCheck are taking information provided by the design team. They're not getting it directly from the manufacturer. So again, that's where we saw that earlier, where they're saying it's going to be a 15, but the table shows it's a 13. Why? Because one comes from it's just a lack of consistency in that design. But ComCheck is stuff I'm putting in the system and it's being assistive. ComCheck is really for the envelope, not necessarily the equipment. And let's just do a quick little example here of a police station, right? We're looking at this heating cooling load calculation for that design. Again, I'm looking at a ComCheck that tells me what kind of systems are going to be installed, verifying that my components are there, right? That we've done some kind of calculation. So I've got my design. I can verify that again we've got some different equipment identified. I see here 3 different RTUs. When I go back to my ComCheck, I only saw 2. So I'm going to ask that question: what happened? Right? I see 2, and then I see 3. And then what they'll tell me is, oh, well, we installed that later. That's a separate unit. Then this is now almost useless. Now I'll use it to evaluate those 2 components, but other than that, it's useless to me, right? And so again, I'm going to be looking at all of those individual pieces and evaluating each one of them, both for mechanical ventilation as well as efficiency. And then more importantly, I'm also going to be looking for those. I want to see that you've got a sequence of operations of how this is all going to work together. We've talked about this one, I think, in some context before, but this is a very unique type of design for an institution that's going to require more than one system. And so those systems need to make sure that we have proper control balancing so that we don't have let's say a rooftop forced air system working against a unit heater or a boiler heating system in an office, right? So we want to have that level, and we kind of see that identified in some of these some of these different calculations, right? Some of these different control sequences that say when this unit is on, this forced air system is on, this uh, boiler based heat, radiant heating system is going to be off. We don't want to cool with one and heat with the other and then create a sauna unless it's intentional. And there have been a few, and I can say this because I used to work in the court system. There were a few interrogation rooms where they did that on purpose. It's cold, but it's hot, right? And it was a bad idea. It just caused moisture condensation and other issues that maintenance hated. But again, there's always going to be different things that we're looking for, right? We're going to talk about, if we're looking at what kind of hydronic heating is being provided, what type of pipe-based, water-based boiler system heating is going maybe to a vestibule. What is that vestibule providing? What's the detail saying? How are we controlling it, right? Are we going to have again, a unit-mounted thermostat that's going to regulate the temperature here different than we see it in the other occupied spaces? Again, sometimes a lot of it comes back to, again, like we said earlier, fan efficiency verification. If we've got fans, exhaust fans, big fans, whatever we've got rolling around the building, we want to make sure that those overhead fans are going to be appropriately selected, I guess is the best way to put it, right? So again, that's something we're looking for as part of that. Is this this is an equipment and this is an efficiency, and what are we doing for air movement? And again, we can kind of see here where we've got some different heating elements, right? And so how is this all working together to make sure that building works effectively? And one thing that I think is important to think about, and this has come up a few times in my plan review processes, especially when we start talking about supermarkets or remodels, and sometimes even new convenience stores, things like that, things that many of us have, or schools, and a lot of places are putting in these little cooler and refrigerated cases spaces. What we want to make sure is that we provide separation and recognition that is a piece of equipment, right? And so sometimes we have to get additional information to identify the code provisions on installation of these materials, right? There are certain lighting controls and anti-sweat controls that we need to integrate into the system or to make sure that we're not getting condensation accumulation in the space between, right, the temperature controlled cooler in this outdoor area. We all go to grocery stores and see, I don't know if you guys, my family, we typically go to our grocery a lot just to go get ice cream. With 4 kids and 2 adults, it's a lot of ice cream goes through the Harmon house. And so we spend a lot of time in the ice cream section. And one thing that drives me crazy is when I see one of my kids holding the door open, right? To look and think. It's like, you're going to get the caramel crunch. I don't know why you're in there scavenging like through the mint chocolate chip. That's not your flavor, man. Right. And so again, that's one of my, I have one son who just, every time he goes, he thinks he's going to try something new. And it's like, no, you're not. So again, we want to have those anti-sweat controls, because if not, we're going to get that condensation accumulation. It's going to create more problems, right? So again, get the equipment information, figure out how it's being controlled, what's the thermal rating of those wall systems, and make sure, this is more my key point here, make sure the building envelope is in and of itself capable of sustaining of meeting the requirements of the code. You cannot incorporate a cooler today and then remove it. We see here we got a cooler, a freezer, a beer cooler, a cooler. So you would almost get the argument that, hey, well, this entire wall, I could reduce the insulation because I've got coolers. No, because once that cooler moves, that wall is now underprotected. Now we need that. So again, we're going to have that clarification, verification of this wall needs to be independent and is independent of that refrigeration unit. So I know that was kind of a quick overview. Any quick questions you guys might have? Just a reminder, if you do, when we do start talking about Manual J, next week we're going to talk a little bit. No, wait, in New Mexico, we're going to talk about swimming. Hope's going to be talking about swimming pools and spas and the energy code relations there. and then we'll get back into mechanical inspections after that. But again, for a quick review or a reminder on manual J's, remember what we're looking for is, again, we've got some documents online to assist you in understanding that process and reviewing it, what to look for in that residential calculation. And again, one thing that I think is important that gets to the heart of why we evaluate manual J's is, again, verifying that what we see in that building, what we see in that design matches with what's in our building plan, right? So we're going to get that list of wall designs, and we're going to verify that those wall designs match with what we see in our building. And then I think a second piece that is also, like I said, critical is identifying, if you got a line set that says 2A1, what does 2A1 mean, right? What is 2A2? I see 8-inch, I see 4-inch, I see 8-inch. What are those? Are those circular, those round, those flat, those oval? What are they? Are they flex? So again, I'm going to want some kind of a diagram to go with it to show me what my inspector is going to be looking for. And again, those expectations for insulation. Looks like I put in here a couple extra slides just in case we needed them to talk about, again, the residential side, the manual J calculations, the expectations for efficiency for the Southwest region. So these are the efficiency rating expectations for new equipment or for equipment. And then let's see, we got a couple. I'm going to look through some of these, see what we got here. Just maybe just an example that used a townhouse, showing that, again, our compliance path, verifying what that compliance path means, that we get that whole approach. And then what I'm looking for is, again, that separation so that I can identify what equipment is doing what, right? So I know that these heating pumps are going to be running individually. They may be located commonly, but they're not going to be operating commonly, right? So I need to know where they're coming from, how they got there, verifying we got the right design values, the right equipment are identified. We evaluate, again, exhaust versus heat pumps versus fan coils, verifying that those are in the right location. Again, this is what I will do. This is how I would run this plan review. Again, I verified my compliance path. I verified my load calculations. And then I start looking at the individual, where they at, what are my expectations. Again, here's my calculation on efficiency ratings and what those different COPs, those values are, right? They're telling me that we're going to use the seasonal performance factor, and this is going to be that value. And so I can compare it. Here's also my SEER value. We're getting a SEER 23, right? And then again, we're going to look for controls. Where are my thermostats and what are they doing? So I think I've got a picture. Oh, I don't have a picture. So of those systems. And again, we've got the same thing happens when we start talking about how we use, again, radiant heating systems, right? We have a centralized boiler system, and then we're running to each of these residential units those pipes in order to distribute the heat efficiently. So again, if you have questions, always feel free to reach out. Trying to get back to as many as I possibly can this week before I get back on an airplane. Again, next week we'll be talking about swimming pools with hope, and then jumping into mechanical systems. Then we'll get the skylights, and then we'll start doing some things with the air barrier and inspections later, installation later. Again, if you have any specific questions, or if you do want to sit down and have and again, let us know if in person versus on virtual. We hear both sides, so sometimes we have to make that call. But if you like virtual conversations versus in-person conversations, let us know so we can get that information out to you and get those all scheduled. The question, how do I watch a previous webinar? Doug, send me an email and I'll send you a link to our YouTube repository. A lot of it was being provided on our website, but because we're transitioning websites, they stopped updating it. But all that's still thrown into the YouTube channel. So there's a YouTube channel out there that has all of our videos. What I'll do is I'll make a note here, and next week I'll put I'll either put it with the certificates or I'll put it in the next week's class. But again, if you do have questions, always reach out to us at the helpline. So you guys have a great week. Be careful, be safe, and we will see you next week.